A Quonset hut can be an efficient, durable, and surprisingly comfortable home, but its curved steel shell creates insulation challenges that are different from those found in conventional wood-framed houses. Steel transfers heat rapidly, and an uninsulated metal shell can become extremely hot under direct summer sunlight, while in winter it can become cold enough for interior moisture to condense on the underside of the metal. Proper insulation is therefore not simply a matter of making the building warmer. It is about controlling heat flow, air leakage, condensation, and indoor humidity throughout the year. The first step is to understand that insulation and moisture control are closely connected in a metal building. If warm, humid indoor air reaches a cold steel surface, water vapor can condense into liquid water, potentially causing corrosion, mold growth, damaged finishes, and unpleasant indoor conditions. A successful insulation system must therefore create a continuous thermal barrier while also limiting uncontrolled air movement and preventing moisture from becoming trapped against the steel shell. Before purchasing insulation, homeowners should inspect the building envelope, determine the local climate, identify existing moisture problems, and decide how the interior will be finished. Inspect the existing Quonset hut before insulating. Begin with a complete inspection of the steel shell, including the roof, sidewalls, end walls, doors, windows, vents, penetrations, and foundation connections. Look for rust, failed fasteners, damaged panels, cracks around openings, and places where rainwater may enter. Do not cover active leaks with insulation and assume the problem has been solved, because trapped moisture can remain hidden for years and cause deterioration that is difficult to detect. Check the floor and foundation area as well, because insulation installed above the walls cannot compensate for major air leakage or moisture problems at the building's lower perimeter. If the hut already has interior framing, determine whether the framing can support the selected insulation system, and whether enough space remains for electrical wiring, plumbing, ventilation, and interior finishes. Understand the local climate and seasonal conditions. The ideal insulation strategy depends heavily on climate. A building in a cold region has different heating and condensation concerns from a building in a hot and humid region, while mixed climates require a balanced approach. In hot climates, the main objective is often to reduce solar heat entering through the metal shell and to keep conditioned indoor air from escaping, while in cold climates, the emphasis shifts toward retaining indoor heat and preventing condensation. For this reason, homeowners should select an insulation assembly based on local building codes and building science principles, rather than simply choosing the insulation with the highest advertised R value. Choose the right insulation strategy. Several insulation systems can work in a Quonset hut, but they do not perform identically. Common approaches include closed-cell spray polyurethane foam, rigid foam boards, mineral wool or fiberglass installed within framing, and combinations of continuous insulation with framed cavities. Closed-cell spray foam is often attractive for curved steel buildings because it can follow the shape of the shell and create a relatively continuous insulation and air control layer when properly installed. However, spray foam requires careful installation, appropriate substrate preparation, correct application thickness, and compliance with fire safety and building code requirements. Rigid foam can also provide excellent continuous insulation, particularly when installed as part of a carefully designed assembly. But the curved geometry can make fitting and sealing panels more labor-intensive. Fiberglass or mineral wool can be effective when installed within properly designed framing, although gaps in compression can reduce performance, and the framing itself can create thermal bridges. Plan the interior framing. Many homeowners create an interior framing system before installing batt insulation or rigid insulation. The framing provides a flat surface for drywall or other interior finishes and creates space for utilities. The framing should be designed around the actual geometry of the hut, rather than forcing conventional rectangular walls into every part of the curved shell. Adequate spacing should also be maintained for insulation so that the material can remain continuous and properly supported without being excessively compressed.
Where electrical cables, plumbing, lighting, or ventilation ducts pass through the insulation layer, their locations should be planned before the final interior surface is installed.
Prepare the steel shell. The steel shell should be clean and reasonably dry before insulation is installed. Dirt, oil, loose rust, and other contaminants can interfere with adhesion for certain insulation products. Small openings around fasteners, penetrations, vents, and service entries should be examined carefully because even tiny openings can allow substantial air movement over time. Repair corrosion and damaged metal according to the manufacturer's recommendations before covering the area. This preparation stage is important because insulation should not be used as a substitute for structural maintenance or water leak repairs. Install a continuous thermal barrier. The most important goal is continuity. Every section of the curved shell should be considered part of one thermal envelope rather than a collection of separate insulated cavities. A continuous insulation layer reduces thermal bridging through framing members and helps maintain a more consistent interior surface temperature. This is especially important for steel structures because steel is a highly conductive material and can rapidly transfer outdoor temperature changes toward the interior. Insulation should therefore be installed according to the manufacturer's required thickness and installation method rather than being added in random layers. Control air leakage. Insulation alone does not stop air leakage. A well-insulated Quonset hut can still be uncomfortable if outside air enters through gaps around doors, windows, penetrations, and joints. The air control layer should be continuous and connected to the corresponding layers around windows, doors, electrical penetrations, and other openings. Seal appropriate small gaps with compatible sealants or materials specified for the application, while larger openings should be addressed with suitable building envelope methods. Door and window weather stripping should also be inspected because large openings can contribute significantly to heat loss and uncomfortable drafts. Manage vapor and condensation. Condensation is one of the biggest concerns in a metal building. The correct vapor control strategy depends on climate, interior humidity, and the entire wall and roof assembly. Do not automatically place a plastic vapor barrier on the interior side without considering the climate and assembly, because an incorrectly positioned vapor control layer can trap moisture rather than solve it. Closed-cell spray foam can provide substantial resistance to vapor movement when applied at sufficient thickness, but its exact performance depends on product specifications and installation. In climates where interior humidity is high, mechanical ventilation and humidity control may be just as important as insulation itself. Pay special attention to the roof. The roof receives some of the most intense environmental exposure. During sunny summer days, the steel surface can become extremely hot, transferring heat toward the interior if the thermal envelope is poorly designed. A properly designed roof assembly slows this heat transfer and reduces the workload on the air conditioning system. In cold weather, the same roof insulation helps retain indoor heat and keeps the interior surface warmer. Roof insulation should therefore be viewed as a year-round investment rather than simply a winter heating measure. Insulate the end walls, doors, and windows. The curved shell often receives most of the attention, but end walls can also become major sources of heat transfer if they are poorly insulated. Large garage-style doors can be particularly challenging because their moving sections must remain functional while still providing reasonable thermal and air sealing. Windows should be installed and sealed according to appropriate building envelope practices, including proper flashing and air sealing around the rough opening. Even excellent insulation cannot compensate for poorly sealed openings, so doors and windows should be treated as integral parts of the thermal envelope. Address the floor and foundation. Heat can also move through the floor and foundation, particularly when the building is constructed on a concrete slab without sufficient insulation underneath or around the perimeter. The appropriate floor strategy depends on whether the slab is new or existing, whether the building sits on a foundation system, and what local codes require. For an existing structure, major floor insulation work can be much more disruptive than roof insulation, so homeowners should evaluate the actual heat loss problem before choosing a solution.
Moisture rising from the ground should also be considered because insulation cannot correct a slab or foundation moisture problem by itself.
Create proper ventilation. A tightly insulated building needs deliberate ventilation because uncontrolled leakage is no longer providing accidental air exchange. Ventilation removes indoor pollutants and excess humidity produced by cooking, bathing, cleaning, occupants, and other normal household activities.
Bathroom exhaust fans should discharge outdoors rather than into an attic-like cavity or the insulation layer. Kitchen exhaust should likewise be designed to manage moisture, odors, and cooking contaminants effectively.
Install the interior finish carefully. After the insulation, air control, and moisture control layers are complete, the interior can be finished with materials suitable for the home's intended use. Drywall can create a conventional residential appearance, while plywood, wood paneling, or other approved interior materials can provide a different aesthetic. The curved ceiling can be used as an architectural feature rather than hidden completely, especially when the interior design embraces the unique shape of the building. Any interior finish should remain compatible with the insulation and moisture control strategy underneath it. Test the insulated building. Once the insulation and air sealing are complete, testing can reveal problems that are difficult to see with the naked eye. A blower door test can help identify significant air leakage, while infrared imaging can reveal areas where insulation is missing, compressed, or thermally bridged. Testing is especially useful around windows, doors, roof transitions, utility penetrations, and connections between the steel shell and end walls. If problems are found, correcting them before final interior finishing is generally easier than opening finished walls later. Prepare the Quonset hut for summer. During summer, solar radiation can place a substantial heat load on an exposed metal shell. Exterior shading, reflective roof finishes where appropriate, insulation, air sealing, and efficient mechanical cooling can work together. Reducing solar gain before the heat reaches the building envelope is often more effective than relying entirely on air conditioning. A well-insulated building should also maintain stable indoor temperatures for longer periods after the cooling system cycles off. Prepare the Quonset hut for winter. In cold weather, the objective is to minimize heat loss while keeping interior surfaces sufficiently warm to reduce condensation risk. Pay particular attention to doors, windows, penetrations, and junctions because these locations often create drafts even when the main roof insulation is excellent. Heating equipment should be correctly sized for the building's actual heat loss rather than simply selected according to the building's floor area. A properly insulated and air-sealed shell can reduce heating demand, but ventilation and indoor air quality must still be maintained.